Okay, so we're going to do a video for the quiz we took in class. I'm hoping, in addition to what we do in class to go over this, this will be just another level of support for you guys to get where we need to with this stuff. So I'm just going to quickly go through, maybe identify the process for solving as well as the actual solution. So this first block of questions here, number 1, 2, and 3, we're all solving equations. And the first one asked me to solve for b, right? So that means, or what I'm trying to accomplish, I guess how it will look at the end is get b by itself. Right? I'm going to make little notes on these. I think part of the video here will be actually identifying the process, not just working the solution. So get b by itself. So if I look closely right now, on the right-hand side, I have BC. That means b is being multiplied by c. So I have a equals BC, right? B and C are being multiplied. So I undo multiplication by division, right? So if I divide by C, those things go away, and C over C is 1, right? So now I have 1B. That's what I want. So if I did it on the right, I got to do it on the left. So I am finished. That's it, right? So B equals A over C. We're just rearranging the equation to get a different variable by itself and to maintain equality. 2 means solve for A. Well, anytime I see solve for, that means get it by itself. So I want to get A by itself. Right now, A is right here. So it's being divided by 2, and then it's subtracting C. So I'm going to do exactly what I would do with this type of problem as if this were numbers, right? If C was a number, I would add C to the other side. So I'm going to do the same thing. So I have A divided by 2 minus C equals N. So some of you don't need to write it in this fashion, but I'll do it for the first one at least, right? So I want to add C, right? That's going to undo this. That's going to make that go away. And if I do it to one side, I have to do it to the other. So I add C right there. So now I have A over 2 equals N plus C. And then I have A divided by 2, right? I don't want A divided by 2. I want A, so I have to undo the division by multiplying. 2 over 2 is 1, and I have 1A. That's what I want. So I multiplied that side by 2. I have to multiply this side by 2. Or the other way I can think of it, I multiplied one of them by 2. I have to multiply all of them by 2. So A equals 2N plus 2C. Another step at the very beginning, maybe instead of doing it that way, I wanted to eliminate the fractions. I could multiply every single thing, by 2. And that would give me, if I distributed, that would take me a slightly different path. I would end up with 2A over 2, right, which reduces down to 1, minus 2C equals 2N, and then add the 2C to both sides. You'd end up in the exact same place. So you could either get rid of the fractions at the beginning or move the term and then get rid of the fractions. You're going to have the exact same answer. Okay, C, or 3 I should say, solve for x. That means get the x by itself. Well, right now there's a bunch of stuff going on. Anytime we have fractions, we decided that probably our method that worked best was to multiply the entire thing by the lowest common denominator. So actually I'm going to do each, and then it would distribute. So we'll just put it on each term. So 6, 2, 1, and 3. Those are our denominators. The lowest common denominator, the smallest thing they all go into, would be 6. So I'm going to multiply every single term by 6. And when I graded the quizzes, I noticed some multiplied by 6, some multiplied by 12, some multiplied by 18, some multiplied them all together and multiplied by 36. I think I even had somebody multiply by like 54, right? And they all worked. In the end, it'll all reduce down. But we're going to choose the smallest one for the easiest numbers. So when I multiply, I end up with negative 6 times 13 is 78. So negative 78 over 6 minus 6x over 2 equals 6x over 1 minus 48 over 3. Remember, when I multiply, I only multiply the tops of a fraction. Multiplication happens on the top. So now if I reduce these numbers, 78 divided by 6 is negative 78. It's negative 13 minus 6 over 2 is 3. 6 over 1 is 6. 48 divided by 3 is 16. All right, so now I have the x's or the whole thing out of fractions. Now I want to get all the x's on one side, so I'm going to add 3x here and add 3x there. So I end up with 9x minus 16 equals negative 13. And then I want to get the x's all by themselves, so I got to get rid of this term here. And so this is a point where I saw a lot of people got this far in the problem and then they made a mistake in these last couple steps. So first of all, keep track of your signs. So I'm adding 16, so negative 13 plus 16. I saw some people gave me a 29, right? But the 16 is positive. This is really 16 minus 13, so that would give me a 3. So 9x equals 3. And then I saw a whole bunch of people got that far. They did all the hard work. They even divided this by 9, and they divided this by 9, which is correct, and they went like this, and they told me x equals 3. All right, but make sure you honor the fraction here, right? So 3 divided by 9 is not, right? Fraction means division, so 3 divided by 9 is not 3, right? 9 divided by 3 would be 3. So it's a fraction I could reduce, 1 over 3. All right, moving down to our next block of questions here. All three of these were systems of equations that I thought would be, well, the first one you could use graphing. I did have a few students get graph paper and graph it and get to the right answer, so that was a possibility, right? This one, the first two really I thought were more set up for substitution, and number 6 was more for elimination, but some people used the techniques we saw to use what they like. But anyway, so let's look at number 4. What I would recommend, y equals 9x plus 2 and y equals 7x minus 4. So if y equals both of those things, then those two things have to be equal to each other. The other way to think of it is, all right, y equals this. So where I see a y in the other equation, I'm going to plug that in there. 7x minus 4 equals 9x plus 2. All right, we have to be able to get that far at least, or else we won't even be on the right track. So now I got to solve, right? From here, we're just solving like always. So get all the x's on one side, so move them over here so they stay positive. And I end up with negative 4 equals 2x plus 2. Get rid of the constant from that side and do the same over here to keep the scale balanced. So 2x equals negative 4 and negative 2 is negative 6. And if 2x is negative 6, I can divide by the 2. Negative 6 divided by 2 is negative 3. So my x is negative 3. Remember, that's only half of my solution. I have to know the x and the y. I'm looking for the point in space where they cross. So now I can take either equation, because remember, this should work for both. So I'm just going to choose this one. Y equals 9x plus 2. And the x is negative 3. So I'll plug in a negative 3 for the x. Negative 27 plus 2. The y is negative 25. And remember, our best answer is to write it as an ordered pair. So we recognize what it actually is, that it's a point in space. Okay, so that one was set up nice for substitution. I did have a bunch of people on number 4 use elimination, and some got it correct, some nearly got it correct. So if you used elimination, or tried to use elimination, and now you're watching the video, maybe you want to try substitution because it's a little bit easier on that one. Number 5, similar idea, right? So I had a few people that tried to use elimination here because they thought the x's are lined up, the y's are lined up, the constants are lined up. The looking at the y's right here, right? The top equation has a -3, the bottom one has a +1. So they thought if I multiply the bottom one by 3, I can use elimination, and that was a really good thought, but we have to have every single piece of our equation lined up for that to work. So not only do the x's, the y's, and the constants have to be lined up, but the equal sign also has to be lined up. The x's and y's need to be on the same side of the equation. So we could move it and make that happen, but I think what's going to be best here is to use substitution. So x equals y plus 1. So we're going to do exactly what we did in number 4. I know x equals y plus 1. So in the other equation, where I see an x, I'm going to replace it with y plus 1. So 2x, now the x is y plus 1. Because that's what the other equation tells me is true. So 2x minus 3y equals -1. And by substituting that in, we no longer have an x in our equation, so we can solve for a y, and then we can plug it back in. So we distribute. And this is another area we want to be careful, right? That two terms with the y's are on the same side of the equal sign. So that just means stick them together. So 2y minus 3y would be -1y plus 2 equals -1. Now we subtract the 2. And -1y equals -3. So if negative, well, we'll just do it the way we should, right? So divide away the -1, divide the other side equally, the signs cancel. So y equals 3. All right, but remember we're not finished. We have to use either of the other equations. This time this one looks much easier because it's already set up for x. It tells me x equals y plus 1. Well, I know the y is 3, so 3 plus 1 is 4, so the x is 4. So my final answer, the x would be 4, the y would be 3. Oops, I should write that. Good point. We were kind of starring our answers. Okay, number 6. Now this one is set up nicely for elimination because if I look at my equal sign right here, and draw a line. On the left side, the x's and the y's are lined up, and on the right side, the constants are lined up. So that's good. It's set up for elimination. What a lot of people missed was I can't just add these together right away. They looked at these two terms and go, oh, they're the same. That's good. But we want to add them and have them disappear. Right? A -2 and a -2 added together would give me a -4. So that means I need to change the sign of one of these equations before I add. So I'm going to change, doesn't really matter, but I'll pick the top one. So I basically am going to multiply every single thing by a -1. All right, and I noticed not many people used my suggestion of dragging them over here. They kept trying to like write new ones underneath here, and then it gets confusing because you're adding, sometimes start adding the wrong ones together. So anyway, so I'm going to just drag it over. So that would be +7x plus 2y equals +13. And then the bottom one, I don't do anything with it. So I just drag it over, add them together. Now I see these two, a +2y and a -2y, when I add them together goes away. So I end up with 8x equals 13 and 11 is 24. So 8 times what would be 24? The x has to be 3. Right, so that's a pretty quick way, if they're lined up, to solve using elimination. So the x is 3. And now I'm going to plug into either equation. So it doesn't matter. I'm just going to pick this one. So I'm going to drop it down here to solve. So x minus 2y equals 11, and the x is 3. So 3, put in red because we got it over there in the red part, minus 2y equals 11. Not sure why that kind of moved like that, but we'll fix it. All right, so get the y by itself to solve for y, right? So subtract away 3, subtract away 3. So negative 2y equals 8, and then divide by negative 2. I got to do the same the other side. So y equals 8 divided by negative 2. That's a negative 4. So my final answer would be 3, negative 4. So 3 different solving systems of equations problems, right? Substitution on the first 2 probably are going to be best. Number 4, sometimes you'll see that called equal value method also, which really it's just saying because y equals one thing and y equals a second thing, that the first thing and the second thing have to be equal to each other. We kind of just represented that with substitution. All right, and then the last 2 down here, and then we're done. I wrote the formula up on the board, and I'll leave it there for the exam next week also. Y equals initial amount multiplied by the multiplier x times. Right, so we have to kind of fill this in. So a student invests $1,000 into an account earning 7% interest annually. Write an equation. So it didn't even really ask me to solve it. Just write the equation that would determine how much money would be in there after 9 years. So if I look at this, it's telling me the initial amount is 1,000, and it's telling me pretty much right away that x is 9. So I know this, and I know this already. The multiplier is going to use the interest rate, right? So I put in 100% of my money, and it gives me back the same 100% plus 7% interest for a total of 107%. But I have to write that as a decimal, so I'm going to write that as 1.07. That's my multiplier. So now I know the initial, the multiplier, and the x. So my final equation, 1,000 times 1.07 to the 9. And I had a lot of people wrote the correct equation and then solved it. Many did it correctly. Some wrote this equation correctly, right? They got this right, but then they told me it was like 9,000 and something. So that tells me what they did was they multiplied 1,000 times 1.07 times 9, right? So remember what, 9 is the exponent. So you're not multiplying by 9, you're multiplying 1,000 by 1.07 9 times. So the calculator will do that for you. You definitely don't want to do it by hand, just to kind of solidify that, right? What this equation here actually means, I have my initial $1,000, and then after 1 year, I would multiply by 1.07. Whatever I get, I could multiply that by 1.07 to get the second year, third year, fourth year, fifth year, right? And we keep going, right? So it's going to be a lot of multiplication, right? Repeated multiplication, that's an exponent. That's why we write it that way. So anyway, I'm going to get rid of that so there's no confusion. That's my final answer, 1,000 times 1.07. All right, and write the explicit and recursive formula for the following sequence. So again, I gave you the formulas on the board, so you had to recognize, let's make this a little bit bigger here. So we had to recognize that this, you didn't have to make a table, but when we did these in class, we made a table, 1, 2, 3, 4, 0. We had to recognize that these were multiplying by 2. And that would means going back this way, this would be 3 divided by 2. So you could probably best would be to write a fraction. Most people made it a decimal, which is okay. So 1.5. So this means what I found here, right? These on top are the n, and that's t of n. So what I found was t of 1 equals, well, let's not do it that way. Let's write the equations like I had them on the board. So we had, if you recognize these were multiplication, then you chose the equations that used multiplication. So the explicit formula t of n equals t of 0 times r to the n. And recursive, t of 1 equals whatever it equals, and t of n plus 1 equals t of n times r. Those were the equations. Copy them down exactly like they look. And then we're going to fill in what we know, right? So it's multiplying by 2. That means r equals 2. So wherever I see an r, I'm going to replace it with a 2. Down here's an r. I replace it with a 2. T of 1 means the value of the first term. So my recursive formula down here, all I got to do is list the first term. Done. Now these two are finished. That wasn't very hard, right? And up here, explicit, I need to fill in the t of 0 term. So I saw a lot of people put the right thing here, but we're still struggling with the notation. So t of 0 means the value of the 0 term. So this whole thing right here means the value of the 0 term, which we found here was 1.5. So we erase the whole thing and it becomes 1.5. It is not t of 1.5 times 2, right? This right here would mean value of the 1.5 term, whatever, right? So basically whatever number would, it doesn't exist, but it would be whatever's halfway between 3 and 6, right? That's what would the 1.5 term would be. So we don't want it written that way because that means something totally different. So make sure you're good with that. So our explicit formula and our recursive formula. So again, all of 8 of these are on, the plus some others, right? There's some other things on there too, but all 8 of these are on the exam for Unit 6. So it's kind of a wide variety. You have to be able to do a number of different things. So practice these. We'll have an opportunity to make up some quiz points if you struggled on these, and then prepare yourself for the exam that includes all this stuff.